Okay, everyone, so here's linear quadratic systems part 2. This is really right now IM3, but it will be IM2 by Christmas time. So anyways, let's take a look at this. So here we have another linear quadratic system. If you look at this first equation, guys, that's actually a quadratic which we've already learned how to graph in IM2. And that right there, of course, is another line, right? A linear equation, y equals mx plus b. And so how are we going to solve this one? Looks a little bit different than the last one, because notice how they're both equal to y already. You guys notice that? They're both already equal to y. So the logic is this. If y equals x squared plus 5x minus 10, but 2x plus 18 also equals that same y, they must equal each other. So couldn't I take, in other words, x squared plus 5x minus 10, set it equal to 2x plus 18, right? And then from there, I have an equation. Notice everything is x's or numbers. So I'm going to be able to solve for x. Matter of fact, it is a quadratic that we're going to solve here, okay? So, remember, to solve a quadratic, it has to equal 0. So the first thing I'm going to do is minus 2x both sides. And if you permit me, I'm going to do 2 steps in one. I'm also going to minus 18 both sides to speed things up just a little bit. Let's see what we have now. We have x squared. 5 minus 2 is 3x. The negative 10, negative 18 is negative 28, equal to, over here we made a 0, we made another 0, so it equals 0. So we have now a quadratic equal to 0, and we're now able to solve it. But for those of you that are in my IM2 right now, guys, you remember how we started learning how to factor? Because that's what I recommend right here. I would not solve this with a quadratic formula if I can factor it, okay? And so let's try to factor it. So in other words, this x squared right here has to be x times x. Again, it equals 0 right there, right? And do you agree that 28 normally is 4 times 7? Excuse me. And a plus 3x would simply be a plus 7 minus 4, wouldn't it? And we have it factored. So again, follow the green. I know x times x is going to be my x squared, right? I know 4 times 7 is my 28. The negative times positive makes it negative 28. And I know that 7 minus 4 is the 3. So I have it factored perfectly. Guess what, guys? We're almost done. Now I'm just going to copy this down on a separate page here. So we ended up with x minus 4 times x plus 7 equal to 0. And as I taught you, IM2, what in here makes it 0? Positive 4 minus 4 is 0. What in here makes it 0? Negative 7 plus 7 makes it 0. So here are my two solutions. But now, let's go back, and we're going to use the second equation since it's linear. It's nice and easy. So check this out. If y is 2x plus 18, I'm first going to plug in the 4. 2 times 4 plus 18. 8 plus 18 is 26, right? So 4 gave us 26. So let me jot it down over here. I know x4 gave us y26. So that's one answer. Now let's do the negative 7 here. If y is 2x plus 18, and we plug in negative 7 for x right in there, we're going to get 2 times negative 7 plus 18. And negative 14 plus 18 is 4. So on the right here, let me jot it down. I know that negative 7 for x gave us a 4. And we found our 2 points of intersection, as we call. We found our solutions. Now again, check it out. I went ahead and graphed it. As you can see in red, guys, which is now yellow, is my quadratic. Okay. Everyone notice the blue line, which is again now yellow temporarily. That's my linear equation. And notice, did they not cross down here at negative 7, 4, and up here to the right at 426? And that is exactly what I got here, negative 7, 4, right? See? And that's what I got there, 426, right there. So guys, that's all there is to these linear systems. You again find a way to combine the equations, substituting one into the other, and then you have to use your algebra to solve it. Until next time, bye.